The pandemic prompted a global surge in vaccine research and development, some of which had already been distributed around the world. Like many of you, I'm excited about these record speed COVID-19 vaccines. But this mRNA vaccine, a relatively new technology that has not been widely used before, may exacerbate public's concern about its safety and effectiveness. So, how do they work and how are they different from any other immunizations? We must first understand how our immune system works.
When a virus enters the body, it injects its DNA or RNA into a cell. In this case, the cell will transform into a virus factory producing new copies of the virus that can infect even more.
But don't worry, our bodies are equipped with a defense system against foreign intruders, also known as the immune system. However, it takes few days for it to figure out how to attack.
Meanwhile, the virus constantly multiplying and spreading throughout the body. From then, symptoms of infection will show up and make you feel sick. The immune system will eventually form antibodies after it figures out how to attack and bind to the virus to prevent infecting more cells and finally destroy them. As can be seen, the immune system is impressive but slow to mount an attack. So, to give it a helping hand, we develop vaccines. Vaccines train the immune system to recognize and combat infection before it occurs. Most of the vaccine we've used contain dead pathogens, living but weakened ones, or just pieces of them. However, they're unavailable to those with compromised immune system and require multiple shots to maintain protection. Thus, testing and receiving approval also takes a long time.
Well, thanks to technological advancement, there's a novel way to develop vaccines quickly, which is a great tool to have on hand in this time of pandemic. The mRNA vaccines.
Unlike other vaccines, these will release genetic material known as messenger RNA. The mRNA from the vaccine contains genetic instructions that only codes for a small part rather than the entire virus. You've probably seen SARS-CoV-2 depicted with spikes, and that's exactly what the mRNA codes for. It's like giving a recipe to make a product. The mRNA enters the cell where the ribosomes read the information and begin to make the spike proteins. Once the protein is created, it travels to the cell membrane and the mRNA instructions will be destroyed by the cell.
So what's good on developing a tiny viral piece in our bodies?
Well, it gives our immune system a sneak peek of what the virus looks like without causing a disease. Antibodies will suddenly detect it, triggering an immune response to recognize and prepare our bodies for the virus. The antibody's memory is stored in B cells so that if future infection with the SARS-CoV-2 occur, the body has now the upper hand.
These mRNA vaccines were designed pretty fast, but that doesn't mean they appeared out of nowhere. Indeed, scientists have long been aware of their potential. These vaccines are effective enough to help get control of the pandemic, or maybe a solution for past and future diseases too.